Hello, and welcome to HelpYourMath.com. Today's video will be covering product rules and how to do them the most effective and efficient way. So here we have the formula which says a function is breaking into two counterparts where there's a multiplication occurring between two x functions. When these two x functions are multiplying, the product rule tells us that the derivative of this product will be the original u function times the derivative of the v function plus the original v function times the derivative of the u function. And once we get to this point, it's good always to simplify your work so that you can always get your critical numbers if need be. So let's take a look at the first problem we have here. Now we notice here I separated this problem particularly this way so that we can see the product occurring. Most of the times we won't get this luxury, but it's good to see a problem that's easy so that we could see it, put it together, do the derivative, and then use the product rule to get the same derivative. So what I'm going to do here first is just put this problem together. And I have for the function of x, I get 3x to the 17th power by using the addition rule for the powers. And what I want to do now is just take the derivative. Here, if I just do the original derivative based on power, I bring the 17 down. 17 times 3 gives me 51. And I subtract 1 from the exponent of 17, which leaves me with just 16. So we see the derivative of this already. But now I'm going to do the same derivative using the product rule. And here we see that we have a u and v, so I'm going to make this my u, and I'm going to make this here my v. So my u is 3x to the 5th power, and my v is x to the 12th. Now my u prime is going to be the derivative of this. So my u prime becomes 15 x to the 4th power by the power rule. Now my v prime, my derivative for the v term, is going to equal 12x to the 11th. The 12 comes down and we subtract 1 to the exponent. Now all we want to do is use that formula right up there. So if I wrote down the formula, u times v prime plus v times u prime, we'll get the derivative of f, of the function of x here. So my u here is 3x to the 5th power, multiplying by my v prime, which is 12x to the 11th. And I'm adding to this my v function, which is x to the 12th power, times my u prime, which is 15x to the 4th. Now if you notice, I'm doing this using these values so that when I'm substituting my terms, it's very easy for me. This is a divide and conquer strategy. It's always good to take advantage of this. Now let's continue this. We have 3 by 12. That's 36. X to the 5th times x to the 11th. That's x to the 16th. So far the left side is good. How about the right side here? Now we have plus x to the 12 times 15 x to the 4th. 15 by 1 is 15. X 12 times x to the 4th is going to be x to the 16th. Now when we sum these two up, 36 plus 15, that's going to give us 51. And the x to the 16 is just the label of it. So here we have our derivative of f, our first derivative of the function of x. 51x to the 16, and that gives us the same thing we would have gotten if we just multiplied these two together. Now as I said before, sometimes it's not so easy to just multiply out a function, and we have to take advantage of using the product rule because it's going to make our lives a lot easier. So this is also another problem we can do just like this first one that we just did here. We can just distribute this x and simplify our work and make it a lot easier for ourselves. In this case we would have x minus x to the 3rd. And the derivative of this is pretty straightforward. We just use the power rule to find the first derivative of x, which is just 1 minus 3x squared. Let's use the product rule and see that it's the same exact work, maybe just a little bit more steps, but if you're looking at problems like these, they're not so easy to do as these are. So it's good practice to get your feet wet if you want to get yourself transitioning from doing an easy derivative to doing a product rule. These are prime examples, right? So let's assign our u to just x. And our v is going to be the second function, which is usually in the parentheses or something. So here we have 1 minus x squared as our second function. So the derivative of the first function is just 1. Derivative of x is 1. The derivative of the v term is going to be negative 2x's because the 1 becomes a 0 and negative x squared becomes negative 2x's. So again, we'll use this formula, u times v prime plus v times u prime. And we're just going to insert them in parentheses for each term. So that u term is x. We're multiplying that by v prime, which is negative 2x's. And then we have plus, and our v term here is 1 minus x squared going in parentheses. And finally, our u prime is just 1. Substituting these values with parentheses makes it all the easier. So now we're just going to multiply this out and add our terms that are alike. X times negative 2x's gives us negative 2x squared. Then we have here, everything just becomes exactly what you see here, because it's 1 times this, and this is a positive symbol, so this is going to come out exactly as we see it. Now all we have to do is combine like terms, and we have our first derivative for this product rule. So this here is going to give us 1 minus 3x squared. Same exact value as we had in the first one. Now, in this problem, we don't have the luxury that we did in the first two. So this is where we're just starting to apply our product rules. So in this case, we want to assign each particular value to u and v right away. So here my u is going to be 4x cubed, and my v value is going to be x plus 1 to the third power. Now this is not as easy as these, as I mentioned before. Here we're using a chain rule for the v term, and for the u term we're just using a simple a power rule. So here we have our u prime is 12x to the second power. Now for our v prime we're using the chain rule, so we're going to say we have 3 times x plus 1 to the second power times the derivative of the inside, which is just 1 in this case. The 1 goes to 0, the x goes to 1, so it's 1 plus 0 for the derivative, and there we have it. So our v prime is just going to be 3 times x plus 1 to the second power. Now the real good news about this is when we're doing product rules, it's alright to end up with a term like this because we won't have to do much. Usually they both do have a common factor, and in this case I think that's what we will have. So here we have the product rule formula, which is u times v prime plus v times u prime, and in this case our u is going to be 4x to the third power. Our v prime is going to be everything we see here, so we have 3 times x plus 1 to the second power. I used brackets to cover it in because it has parentheses in the term. For the second term here we have plus our v times u prime. So our v is going to be x plus 1 to the third power, and our u prime is just 12x squared. So we're multiplying this by 12x squared. Now it's very important that when you get to this point you look at these two and you say, what's the greatest common factor? Well, 3 times 4 is also 12, and this has x cubed and this has x squared, so we know they both have at least 12x squared. So let's factor that part out first. What else do they have in common? So what's left over here so far? So far all I have is an x, but what about this? This is x plus 1 to the second, and here I have x plus 1 to the third. So they both also have x plus 1 to the second power. So what's left over after I factor all of this out? I'm using this to divide all of this. This goes away. The 12 is 3 and 4, and x squared leaves me with just an x in here. How about for the second term? I'm using all of this to divide all of this. 12x squared goes away perfectly, and all I'm left with is x plus 1 to the first power. So I'll drop this in here in parentheses. Now let's simplify our work, and it's perfectly factored and ready to solve for critical numbers if you ever have to do that in a test or so. So here we have 12x squared, x plus 1, second power, and for the last term here, x plus x are 2x's plus 1. This makes it very easy to solve for your critical numbers. So keep in mind that if you keep factoring these, you'll get your work more than halfway done. Now for this last problem, for number 4, I'm going to bring it all the way back over here since we're not using this side of the board right now. So let's take a look at this question, and we have 4 is the function of x equals 3x plus 1 to the second power times the square root of 1 minus x squared. This one's probably the toughest problem of all of them. In this case, we have 2 chain rule problems that we're going to do. The first step, though, in this case, because of this radical, is we're going to change the sign to a power function. So we have f of x equals 3x plus 1, second power times 1 minus x squared to the power of 1/2. All right? That's our square root power, and now what we have to do is assign our u and v and get the simplifying, all right? So u equals 3x plus 1 to the second, our v equals 1 minus x squared to the power of 1/2. Now remember, in chain rule, what we're doing is the same thing we did in problem 3. We want to bring down the power, keep the term the same, subtract 1 from the exponent, and multiply by the derivative of the inside. So here what we're going to get is u prime, and our u prime is going to be 2 times 3x plus 1 times the derivative of the inside, which is just 3. Let's simplify this out a little bit. It looks a little more friendly than it does. I'm just going to have this 3 and this 2 multiply and leave it just there. So here I get 6 times 3x plus 1. This I don't care too much about because I'm sure there'll be a common factor with it. Let's see the v prime now. Let's just bar this off. The v prime is going to be 1/2, 1 minus x squared to the power of negative 1/2. After I subtract 1 from 1/2, I get a negative 1/2. And this is going to multiply by negative 2x's for the derivative of negative x squared. Now let's bring this all together. This is going to go down to the denominator and join the 2 here. These 2's are going to reduce to 1. So this is just going to be in the denominator by itself. So I have v prime equals the fraction with this in the bottom with a positive 1/2 value when I move it downstairs. The negative 2 and the positive 2 here are going to reduce to 1. And I'm just going to have a negative x as the numerator. So this one's a negative fraction. So now let's put it all together, right? We have u times v prime plus v times u prime. So our u value, again, we have 3x plus 1 to the second power. Our v prime term is this one. We have negative x over 1. Let's use a bracket here. Minus x squared to the power 1/2. And here to this, we're going to be adding the second terms. So here we have v times u prime. Our v term is 1 minus x squared to the power 1/2. Our u prime term is going to be 6 times 3x plus 1. So we have 6 times 3x plus 1. Luckily, the 3x plus 1 is going to come in handy. But the bigger picture here, the bigger problem we have is that we have a fraction on this side. So let's join these 2 together, right? Let's not join anything and just factor out that common factor piece, right? We have the 3x plus 1 for both terms. And then we'll do some work with what's left over, all right? So here we're going to take out the 3x plus 1 from each one of these. And this is going to have one of them left over. So the leftover piece is going to multiply by this negative x, which is also over this 1 take away x squared to the power 1/2. On this side, we have a 6. The 3x plus 1 comes out, and we also have this term, and we're going to put all of this over 1. So we're going to have plus 6 times 1 minus x to the second to the power 1/2. Now, we're not completely done yet because we see these don't have the same denominator. We're going to add a 1 under this, and we're going to complete the LCD. The good news is, when I complete the LCD between these 2, I'm going to multiply the top and bottom by this term. Luckily, we have the same term on top, so this times this is going to give me just what's inside without the exponent. But on the bottom down here, I'm going to have 1 minus x to the second power to the power 1/2. And that's going to multiply by the top and bottom here. So I'm going to have this here inside the parentheses occurring. Now, since these are the same, I could just technically get rid of this exponent and this term, and I'm just going to be with this here. So let's just erase that part since I'm running out of space. And this is what I'm going to be left with. So let's say what we have next is 3x plus 1. And on top here, I'm going to have negative 3x squared minus x. And here, when I distribute this, I'm going to have positive 6. And then I'm going to have negative 6x squared. And all of this is going to be over just 1 minus x to the second power to the power 1/2. And now I could combine like terms on top. And then we're almost done. So this is also just multiplying by the numerator. So we have here just 3x plus 1. Then we're going to have here negative 6x squared with negative 3x squared will be the final term. I'm going to start with the 6 here. Then we have a negative x. And then we have negative 9x to the second power. And all of this is going to be over 1 minus x to the second and the power of 1/2. Now, is this factorable 54? I don't think so. And so this is just our derivative here. Thank you.